Hi, I'm James Verdier, and welcome to the American Institute of Biological Sciences BioScience Talks, which is a forum for integrating the life sciences. On the second Wednesday of each month, we discuss the latest bioscience publications, and as a reminder, if you'd like to read more, point your browser to academic.oup.com/bioscience. For today's episode, I'm lucky enough to be joined by two guests. Dr. Jennifer O'Leary is a California Sea Grant marine biologist based at California Polytechnic State University, and Dr. Fiorenza Micheli is a professor of biology at Stanford University, and she's based at Hopkins Marine Station in Monterey. And they're here to talk to us today about resilience in marine ecosystems and how those examples of resilience may be used in future management. And we had a great chat with a lot to talk about, so let's get straight to the interview. Drs. O'Leary and Micheli, thank you very much for joining me today. Before we get started in really talking about your article in particular and the study that you conducted, I was hoping you could give us a brief overview of resilience in general, and what does that mean in these types of ecosystems? And I'll just throw that open to whichever one of you'd like to take it first.
Yes, so there are many different definitions of resilience, but the one that I really like the best, that I think is the clearest, is resilience as the capacity of an ecosystem to absorb disturbances and still retain their function. So this means that an ecosystem might change as a result of a disturbance. There may be a change of species or a change in the habitat, for example, but that ecosystem continues to function, to be productive, and to support diversity in spite of the perturbation.
Okay, and to just kind of frame that and crystallize it for our listeners, I was wondering if you could give us an example. Are we talking about things like coral reefs when we're discussing these sort of coastal marine ecosystems?
So these ecosystems could be coral reefs or reefs made by oysters or other marine invertebrates. It could be algal beds or seagrass beds. And when these systems are resilient, what we mean is that after they're affected by a disturbance, a heat wave or a storm, they continue to be productive and to support the thousands of species that are associated with these reefs or algal beds or seagrass beds.
And Dr. O'Leary, anything to add?
Yeah, I just wanted to add that there's basically that when we think about resilience, there's two ways that an ecosystem can continue, as Fio said, being productive after a big disturbance. And she mentioned a couple of them, like storms or a big heat wave. And usually either the ecosystem will decline. So as in a coral reef, the coral cover will go down, or in a kelp forest, you'll lose some of the kelps themselves that provide the habitat for the whole ecosystem. But after the disturbance goes away, they can recover. And so recovery is one mechanism. And the other way that resilience can happen is that a disturbance comes and the ecosystem actually doesn't change. So it's able to maintain itself with all the corals or seagrass or kelps, even during that disturbance, and then maintains its function afterwards.
Okay, great. And, one of the things you've both mentioned now is disturbance. And, I was just hoping you could tell us a little bit about the types of disturbances we're discussing here. Are these individual events that are sort of discrete, or are we talking about, kind of the larger scale, rise of sea level, that sort of thing?
No, these events can be discrete. For example, it could be a major storm or a flood that brings fresh water into the coastal environment and affects marine species. But there could also be persistent disturbances. For example, the gradual acidification of the oceans or a gradual temperature increase. So both types of events are disturbances, can be considered disturbances, but they act over very different time frames.
Okay, so we've got a variety of disturbances happening over very different timescales. One other thing I was wondering about disturbances is, are we seeing more of them? Is this something that's responsive to climate change? And is it the case that, we're seeing more perturbations to ecosystems than we have in the past?
We are indeed seeing an increased frequency of disturbances, and sometimes the severity of the disturbances has also been increasing. And an example are the two warmest years on record, 2016 and 2015, that have profoundly affected marine systems worldwide. So there's been an underlying trend for warming, but also recent extremes that have had profound impacts on marine ecosystems. Some ecosystems worldwide, for example, the California current, now where I live and work, are naturally highly, highly variable. So sometimes it's difficult to discern, to separate the trends of frequency of disturbances on the backdrop, on the background, on this really high variability. But for several types of disturbances, there's evidence that their frequency and sometimes severity has been increasing. And the underlying cause, there's broad consensus that the driver of things getting worse is global climate change.
And now, if you don't mind, I'd like to move a little bit into your particular article. And you were studying resilience broadly and, trying to find evidence of it, if I've interpreted correctly, across a variety of ecosystems. And I was just hoping you could tell us a little bit about the methodology and, how you went about looking at such a, sort of broad sample.
Sure. Yeah, I think maybe going back a little bit and talking about what motivated us to do this study might be useful before launching into the methods. And I think what we acknowledged within our working group is that there are these increasing climatic disturbances, and as Fio just explained, becoming more and more frequent. And that certain ecosystems are especially sensitive to those, ecosystems that are near the coastlines and that are dominated by living habitats. So things that we've mentioned like seagrass and kelp forests and oyster reefs and coral reefs, as well as mangroves and salt marshes. And that there's this massive number of papers documenting that there are a lot of declines. And I think that's a really important point, is that we do not argue with that. And we agree that, with the 200,000 plus papers that have come out since 1984 showing that climatic disturbance is really hitting these ecosystems hard. But we were also interested in using a technique called bright spots analysis to look at those cases, which we thought would be relatively rare, where ecosystems persisted or showed resilience despite having these intense climatic impacts or long-term climatic impacts. And so this is a technique that really was developed in the health field, where I think it was in a developing country where they went in and looked at malnutrition amongst children, and a lot of the children were malnourished, but they were able to identify a few that were not malnourished, and were able to look at what were the factors underlying that, what were those children or parents doing differently. And so we wanted to take a similar approach to this study. And so we did a couple of things. So we basically elicited expert examples and opinions from 300 people who had published very frequently in these 6 ecosystem types we were focusing on, and then also asked them to recommend the most important papers. And so we were able to look at how many cases amongst those experts who responded had seen climatic disturbance, and then what % of them had seen resilience. We were able to get their opinion on what they felt were important factors in helping ecosystems be resilient or less resilient, as well as pull that information from their examples. And then finally, we were able to review the literature they recommended and look for examples and factors that might contribute to resilience from there.
Okay, and so when you're looking at bright spots, what's the reasoning behind that? Why are they so important?
Sure. So I think bright spots are incredibly important, because if we can find ecosystems that do persist or recover in the face of some sometimes very intense climatic trauma, then we can understand whether they had certain conditions or certain management going on that allowed them to do that, and use that to inform how we might approach other ecosystems and manage for increased resilience across the board.
Okay, and Fio, was there anything you wanted to add there?
The scientists in our group of co-authors have spent years to decades documenting impacts on marine ecosystems. And we have come to realize through our work that in addition to showing what is happening, all the negative impacts, it's so important to actually show that there are also examples of things turning around and getting better. And our motivation behind this study was to look for this example, ask the questions of where and under what conditions they occur, and also, really, maybe most importantly, try to understand what were the circumstances, what are the conditions that lead to these positive outcomes, so that ultimately, as natural resource managers, as decision makers, we can also to try to recreate these conditions and promote the recovery or the resilience of impacted ecosystems. So really our motivation was one of asking the questions, where do bright spots occur and why do they occur? And shift the focus from impacts to resilience.
Okay, so the idea essentially then is to figure out where the ecosystems are doing well so that you can then try to, through management actions, recreate that elsewhere.
Yes, I think it's really important to see where and why some ecosystems are doing well, because these cases, even if there aren't that many of them really, they really help us understand what could be done to try to make these instances more common as we are moving forward and facing more extreme conditions. So it's they're lessons for us. And if we understand what has happened in those cases, we might be able to promote these, these instances more broadly.
Okay, and I'm very eager to talk, more about what sorts of circumstances tended to be associated with resilience. But first, Jennifer, I wanted to touch on something you mentioned, which was that you'd expected to see relatively few of these examples of resilience. And you kind of hinted that you might have seen more than that. Just sort of looking at it from a very broad perspective, were you seeing more cases where, ecosystems were holding up and continuing to provide services, et cetera, perhaps more so than you'd originally expected?
Well, I was very surprised by our one of our primary results, which is how many of the experts actually did see resilience within their career. So probably going into it, I had expected that maybe 50% or less of the experts would have seen, examples of strong resilience. And we had 97 experts respond to our survey. We sent the survey out to about 300 people. And so getting, almost 100 was a pretty good return rate. Of those, a quarter had never experienced climatic disturbances. So we had to kind of not look at those in terms of, this particular study. But of those people that did see climatic disturbances, we found that 80% of them provided examples of resilience. And so that exceeded my expectations of how many, would see that. But I would like to emphasize that it doesn't contradict how bad the impacts of changing climate and these climatic disturbances are on ecosystems. So essentially what we're asking is, in your career, which for most of these people had been relatively long, so, around 20 years at least of experience, have you ever seen an example of resilience, which isn't the same as saying, every time you see a disturbance, are you seeing resilience? But nonetheless, in 80% of these people's careers, they had seen a climatic disturbance and seen an ecosystem either recover or resist that disturbance. And so I found that to be very hopeful that you can actually go out and identify these bright spots or places that provide us hope, and that we can study to understand how they work and what's behind that resilience.
And Fio, did it match your expectations as well, or what did you expect to see in terms of the frequency?
I had also gone in expecting much fewer instances of resilience, both among the experts that we consulted and in the literature, because we also reviewed papers and found similar proportions of papers also reporting instances of resilience as the experts. So I was also surprised of how many instances were reported and how many of the scientists that we consulted and the papers that we read actually had encountered resilience.
Okay, and now that we've sort of got a baseline idea of why resilience is studied and what possible applications it might have, which I hope we'll get more into in a little bit, I was hoping you could tell me a little bit, and Fio, we'll start with you, about what characterizes resilience in general. Were there common factors? What allowed an ecosystem to persist and successfully recover from a disturbance when others may not have?
So first of all, I want to talk a little bit more about resilience, because resilience has two different components. One is, and that's normal, that's generally called resistance, is when a system, an ecosystem, doesn't change very much following a disturbance. The second component is, instead it's called recovery, is when a disturbance may affect an ecosystem. For example, in the case of a coral reef, there might be high mortality of corals, but what happens then is that the recovery, the new colonies, for example, of corals coming in, happens very quickly. So these two components add up to overall resilience, but through very different processes. We found that both resistance and recovery, so resilience, tended to occur under particular conditions. And this, probably the top of the list, included disturbances that didn't completely eliminate the habitat. So, for example, for the coastal habitats that we considered, salt marsh, oyster reefs, coral reefs, algal beds, the disturbance didn't remove all of the individuals that form those habitats. There was a lot of habitat left. So that was one characteristic of resilient system. It was the disturbance that didn't completely eliminate them. Another characteristic was a high rate of input of new individuals. And so this is what we call the high recruitment or connectivity. Basically, there are new individuals. For example, in the case of marine species, often arrive in that ecosystem, recruited to the ecosystem as larvae, for example, or juveniles. And there was a big supply of these new individuals from populations that were persistent within the ecosystem or nearby. In addition to these two characteristics, the ranking third is the physical setting of those systems. The bright spots tend to occur in places that have specific characteristics. For example, in terms of their depth, or in terms of their overall temperatures and currents affecting the temperature of the seawater, they tended to provide a local refuge or a local pocket of resistance from the extremes. So where those systems are is very important. And also we found finally that the management of those ecosystems, what people did to protect those systems also mattered. And so management that removes additional stressors from fishing, for example, or pollution, tended to be associated with high resilience as well.
Okay, so for an example of that last point, would something like management in which oyster take were reduced after an extreme storm or something like that. Is that the sort of thing you're talking about?
Yes, this would be a good example of the management that avoided that extreme impact on the system that I mentioned. So management that ensures that some of the habitat is left to promote recovery would more likely lead to high resilience than the absence of those initiatives.
One thing I'm interested in is how those first three that you mentioned, though, could be affected by management. Is there any way that a manager can, intervene in any way in an ecosystem or manage an ecosystem, say to increase the likelihood that they'll have, a greater input of, replacement organisms if something bad were to happen to that ecosystem?
Yes, very much so. So management that is proactive, that basically avoids getting to the point where things are really, really bad, would be an example of management targeting those factors that I mentioned. And this is in particular related to the first two factors, the remaining biogenic habitat and the maintenance of recruitment and connectivity. Because if management, for example, through regulation of fisheries, prevents the depletion, the excessive depletion of population, that would lead to remnant populations being able to reproduce and replenish sites that are impacted. So that would be an example. Another means of achieving this objective might be to the establishment of protected areas, of places in the oceans where impacts are removed. For example, they're protected from fishing or from other forms of take, and these pockets, these refuges are maintained to avoid population depletion. So management can proactively maintain the conditions that promote the factors that seem to be most strongly associated with resilience.
It might help to give an actual, physical example of how these things might work. So, marine protected areas, which Fio mentioned, can be incredibly important in actually all three of these factors. So in physical setting, where you put it in relation to sediment sources or upwelling of nutrients or how deep these things are, it can have a tremendous influence on resilience of ecosystems. And so that plays a really big role when you're setting up marine protected areas. And then the role of the marine protected area is then to do things like maintain the habitat and provide for additional recruitment. And so, in work that I do off the east coast of Africa, there's a series of marine protected areas that were put in the 1960s and that contain the last remaining intact coral reef and seagrass beds in a lot of the countries there. But they do require active management. And so despite having these marine protected areas in place, you can see declines happening to both some of the major habitats, which include corals, mangroves, and seagrass. And so in one of the areas, managers saw that right outside of the fisheries closure, which is part of the marine protected area, there were tremendous declines of seagrass because of certain types of gears that were being used, dragging nets across the bottom. And they worked with fishermen to reduce and remove the use of those gears and focus on more sustainable approaches to harvesting fish. And as a result, we're now seeing the seagrass rebound from that, providing more habitat, which will help that system resist future climatic impacts, and also provide a greater potential for regrowth through clonal vegetation growth as well as seeding.
That's a great example. And it kind of makes me wonder, to what level is that sort of practice, taking into account these sort of bright spots analysis and that sort of effective management, is it really being performed? Is this something that's being done on a widespread basis, or is there still a lot of room, in this ecosystem management to really make some great strides?
I think that, that generally it tends to be a gap between science and management. So there's some really important information that scientists are producing, but I think it doesn't always get to managers in the most effective form. And there's some barriers to managers accessing that information. So for example, scientific papers sometimes are difficult places for managers to actually get information. And so in my opinion, one of the big needs really is to support what managers are trying to do by thinking about how we as scientists can engage with them and make sure we're doing the research that addresses management needs, and also make sure that our findings go back to managers in ways that are easy to understand and that work within their management frameworks to make decisions. And I think both Fio and I have in our careers focused on that. Myself and I just talked about examples with marine protected area management in Africa, but also working here in California with nearshore ground fishermen and working with them to assess the impacts of MPAs by using their fish traps inside and outside of marine protected areas and looking at how fish are changing over time since those were only put in 2007. And Fio can probably talk about examples from her work with abalone in Baja California.
So fisheries management, I would say in general, is most definitely taking important steps forward. And for example, the consideration of important coastal habitats, like the ones that we included in our studies in fisheries management plan, and the protection of these places that are so important for targeted populations has become part of the approaches to management and mandated, in fact, in the new fisheries management policies in the United States, in Australia, in the European Union. So that is it's becoming basically more and more common to include this consideration: marine protected areas, critical habitat, essential habitat. There is still a lot to do, and there are still major declines in fisheries worldwide that need to be addressed. The example that I have been working on, the system where I have been working in for the past decade or so, is a really great model, I think, of where fisheries management could go towards in the future. I have been working with a series of fishing cooperatives in Mexico, and these fishing communities were received access rights by the Mexican government starting in the 30s and 40s last century. And what that means is that they have exclusive access to some of the species that they fish, like lobster and abalone. So they manage areas of the oceans. They have this concession, these territories, essentially, where they manage the fisheries, and they can establish voluntary reserves. For example, they have done that in many cases. They can decide to change their fishing quotas, to change their fishing season, to switch between different species. So there's this local, basically, bottom-up approach to management that has proved really successful, especially when combined with strong fisheries policies at the national level. So these systems don't only exist in Mexico. This similar approach has been used in Chile and in the Philippines and in many other places. And so there are some really great models, I think, that can be maybe scaled up and implemented more broadly.
Great. That's fascinating. It sounds like it gives them a greater personal stake in the well-being of the ecosystem than they might otherwise have.
Exactly. That's because basically these communities, for example, in the case of Mexico, they are entrusted with these public goods, with the fisheries resources for 20 years. So there's really this long-term view of implementing good management and maintaining these resources for a long time. And that completely changes how management is done.
Great. And you may have just partially answered this, but I'm wondering what's next for this research. What are the next steps? What are the still unanswered questions? What will you be studying next?
Given that this paper was focused on looking at scientists and looking at their experience and their knowledge and getting their recommendations on key information sources, we'd like to repeat this study, looking at managers and asking them similar questions and seeing how different their perspectives are to those of scientists, and how many managers around the world have encountered these bright spots and what they have seen as the most important factors leading into this. And I think one thing that prompted that is that in our study, in the opinion of scientific experts, they felt that local management should be very important, but in their examples, it rarely came up as a key factor. And so, it may be that management isn't having as much of an impact, but it could also be that scientists are just not as aware of management happening on the ground.
And that's work we'll definitely look forward to reading about in the future. And I think it's also a good place to leave it today. Thank you both very much for joining me.
Thank you so much for having me.
Pleased to be here.
And that concludes this episode of BioScience Talks. Just a reminder, the journal BioScience is published by Oxford University Press on behalf of the American Institute of Biological Sciences and is made possible by the support of our members and donors. Thank you, and talk to you next time.